Rational and irrationals are the first topic we'll cover. Rational numbers we covered in class. Reminder that rational numbers are any numbers that can be written as a fraction. As a decimal, what they look like, they are terminating or repeating decimals. So an irrational number is basically a number that can't be written as a fraction, cannot be written as a fraction. As a decimal, normally they're not perfect squares. Other types of irrational numbers would be pi. Pi goes on forever, it never terminates, it never repeats. So examples here of a rational number. Obviously this is a rational number here, this is a fraction. The square root of 4, we know what that is. The square root of 4 is 2, and 2 can be written as a fraction as 2 over 1. The next decimal, it terminates, it stops, therefore you can write it as a fraction. And the next decimal is also a rational number as it repeats. Below are examples of irrational numbers. You have pi that goes on forever, it never repeats, it never terminates. We also have the square root of 2. We don't know what the square root of 2 is. That's also going to continue on forever and never terminate and repeat. Other things, square root 3, square root 17. You don't know what the square root of those numbers are. They are not perfect squares. Therefore, they are going to be an irrational number. Couple examples they give us. Example 1, prove that decimal 8.72 is rational by finding the fractional form. Reminder in class here, you always look at the place value here of the last digit. That 2 is in the hundredths column. So that is why that decimal is going to end up over 100. The 8 here is your whole number. The 72 is the fraction part. You can really make this 872 over 100. So you look at the last digit and then you write the number over the place value. So we have 872 hundredths eventually needing to be reduced, but however it is a fraction, therefore it is a rational number, so you've proved it. Example 2, which of the following best describes the set of numbers shown below? A, they're all rational numbers. B, irrational numbers. C, both rational and irrational numbers. Or D, neither rational nor irrational numbers. Well, if we look at the first one, 4 1/3, that is a fraction. And remember, all fractions are going to be a rational number. The next one we have is 297. That would be a whole number, and you can write that as a fraction, put it in it over 1, so therefore 297 is rational. We look at this decimal here, 14.256. It terminates. Terminating decimals are rational numbers. We look at the square root of 25. We know what the square root of 25 is. That is 5. So it's a perfect square. This is also a rational number. And then the only other one that we have up here is the square root of 7. We do not know what the square root of 7 is. That is not a perfect square. Therefore, this is an irrational number. So in this set of numbers, what we have is option C, both rational and irrational numbers. This will conclude rational and irrational numbers.